Title: The Plywood Palace of Pudong. How Shanghai's elite glass tower became a 60-story guillotine. Upbeat, urgent cable news music kicks in, drum hits with high-octane synths. Narrator: VO. Imagine a 60-story blue mirror. A razor-edged, minimalist rhomboid masterpiece designed to reflect the historic architecture of East China right back at itself. A structure backed by one of the largest financial conglomerates in mainland China. The original budget? A staggering 500 million yuan. The reality? A construction disaster so severe that the total tab crossed 1 billion yuan. The surrounding streets were turned into literal combat zones. And the very company whose name was stamped on the lease was legally barred from moving in. This is not a hypothetical worst-case scenario from an engineering textbook. This is the terrifying, documented history of the Guanghua Tower in Shanghai. The day a hyper-ambitious architectural masterpiece became the most dangerous high-rise in Asia. Graphic fly-in. The architectural dream vs. the urban nightmare. Narrator: In 1977, the National Architecture Association issued a prestigious honor award to a landmark tower in Shanghai's premier commercial district. There was just one massive, embarrassing problem. For the previous 5 years, that exact same skyscraper had been dropping 220-kilogram glass panels directly onto the crowded sidewalks below. We are talking about a luxury facade so utterly compromised, so thoroughly shattered, that more than an acre of this multi-million-dollar glass tower had to be boarded up with cheap painted plywood. A skyscraper that required 1,500 tons of emergency steel bracing installed post-construction because structural engineers suddenly realized a strong crosswind from the East China Sea could literally topple the entire structure. How does a mega project backed by elite state-backed capital go this catastrophically wrong? Map animation. Zoom down to Shanghai, Clarendon Street, equivalent. Limy Road, Copley Square equivalent. Wenhua Square. Narrator: VO. To understand the collapse of this architectural dream, you have to look at the sheer corporate hubris of the late 1960s and early 1970s. The Huaxia Mutual Life Insurance Company wanted a flagship headquarters that would scream financial dominance. They hired the world-renowned firm of Chen & Partners, and the master design fell to Lee Henry, a legendary architect known for ruthless geometric minimalism. Lee's concept was breathtaking. A sheer, unbroken blue mirror with no ornament, no setbacks, and no visible external structure. It was designed to rise directly adjacent to the Shengji Temple, a stunning 19th-century brick and timber Buddhist masterpiece, and a designated National Historic Landmark. The reflective glass was supposed to be a supreme gesture of respect, a modern tower honoring its ancient neighbor by mirroring its sweeping gables. Instead, it nearly pulverized it. Archival footage, dramatic reenactment, cracking earth, warping steel. Narrator: VO. The disaster didn't start in the sky. It started deep in the treacherous mud of Shanghai. The entire district is built on reclaimed tidal mudflats, soft, wet, highly unstable silt. In 1968, as crews excavated the massive foundation, the temporary steel retaining walls warped inward like wet cardboard under the immense lateral pressure of the surrounding muck. The ground shifted. The displacement rippled outward. Sidewalks cracked open, water mains burst, and across Limy Road, the ancient walls of Shengji Temple began to literally rip apart. The historic brickwork split along centuries-old mortar joints, priceless interior murals flaked into dust, and the temple's foundations began sinking into the abyss. Before a single pane of glass was even installed on the Guanghua Tower, the developers were already hit with a massive multi-million yuan lawsuit by the Cultural Bureau. But the destruction of the temple's foundation was just a warm-up act. The real crisis was about to fall from the heavens. Sound effect. Explosive shattering glass. Narrator: VO. 10,344 insulated glass panels, each one measuring nearly 4.5 meters tall, weighing over 200 kilograms. This was the blue skin of the Guanghua Tower. And in 1972, as construction neared completion, they started popping. On January 20th, a massive winter storm slammed the coast of Shanghai, bringing 120-kilometer-per-hour gales to the upper floors. What happened next was absolute carnage. 65 massive panels failed simultaneously, detaching from the steel frame and tumbling hundreds of meters through the air. striking the streets below like supersonic guillotine blades. Over the next few months, more than 100 panels obliterated themselves on the pavement. The Municipal Construction Commission had seen enough. The Shanghai police completely sealed off the entire commercial district whenever winds exceeded 45 kilometers per hour. An elite billion-yuan corporate headquarters had become an active, lethal hazard zone. And the most terrifying part? Nobody knew why the glass was falling. Fade to black? Sound effect. Deep, ominous metrical hum underpinned by wind-howling narrator, VO. As the glass rained down onto Wenhua Square, a total communication blackout descended on the Shanghai project. This was a premier financial development in mainland China, and the shame of an elite high-rise raining shards over a historical landmark was completely unacceptable to the municipal authorities. A culture of intense legal defensiveness took over. The developers at Huaxia Mutual Life Insurance, the state-backed contractors, and the manufacturing plant in Zhejiang entered into strict, ironclad non-disclosure agreements. Technical findings were locked away. The public was left in the dark, staring up at a 60-story safety hazard. But you cannot hide a broken skyscraper. To keep the public safe, engineers had to act fast, and their solution was as primitive as it was embarrassing. They sent maintenance crews up the scaffolding with thousands of sheets of heavy, thick industrial plywood. One by one, every single broken, cracked, or suspect glass pane was pried loose and replaced with a sheet of wood painted to look vaguely like blue glass. Graphically VIN, the typical skyline transformation, from futuristic to fabricated narrator VO. More than an acre of this cutting-edge curtain wall was replaced by a patchwork of raw timber. The sleek, futuristic mirror that Lee Henry designed became a giant, vertical checkerboard. Local citizens and media didn't hold back. Radio hosts mocked it daily. The building was given two biting nicknames that stuck for a generation: the Plywood Palace of Pudong and the world's tallest wooden high-rise. Huaxia executives were furious. They had over 600 million yuan in sunk costs tied up in a structure that was completely uninhabitable. Here was one of the largest risk assessment corporations in China, a massive insurance giant whose entire business model was predicated on calculating and pricing risk. And their own flagship corporate headquarters had become the single most visible financial and structural risk in the country. Graphic, engineering exploded diagram, cross-section of the original dual-pane window unit's narrator. VO, while the public laughed at the plywood. Elite forensic engineering teams from the China Academy of Building Research were working behind closed doors to figure out the technical mechanism of the failure. Early theories blamed structural movement. Investigators hypothesized that the tower was swaying too aggressively under the high-altitude winds of the Yangtze River Delta, creating localized aerodynamic pressure hotspots that simply popped the glass right out of its channels. Others argued that the severe ground settlement from the catastrophic foundation dig was twisting the structural steel frame, the window frames out of alignment by crucial millimeters, and snapping the glass under immense shear stress. But when the forensic lab results finally came back, they revealed an explanation that was far more mundane, far more damning, and an absolute disaster for the manufacturing process. The problem wasn't the wind. It wasn't the soil. It was the engineering of the glass units themselves. Animation. Closer zoom on the chromium coating and rigid solder bond narrator. VO. The original curtain wall used advanced dual-pane insulated units. To achieve that brilliant, seamless blue mirror aesthetic, a highly reflective chromium coating was applied to the inner surface of the outer glass pane. To bind this heavily coated glass to the structural metal frame, the factory utilized an incredibly rigid lead-based solder. On paper, it looked bulletproof. In reality, it was a structural death sentence. Skyscrapers are living, breathing entities. As the harsh Shanghai seasons changed, from scorching summers to freezing winters, and as wind currents vibrated the vast exterior facade, the massive 4-meter glass panels naturally needed to expand, contract, and flex. But the ultra-stiff, non-yielding solder bond refused to budge. It completely locked the edges of the glass in place, because the mounting system could not accommodate even a millimeter of natural thermal or mechanical movement. Those extreme physical stresses were transferred directly back into the glass panes. Microscopic fatigue cracks began to propagate silently through the chromium-coated layers. It was a ticking time bomb. The windows were being slowly, systematically broken by their own mounting brackets day after day. When a high wind event or a sudden temperature drop hit the city, it merely pushed the already fragile glass past its ultimate breaking point, shattering the inner structures and releasing 220-kilogram sheets into freefall. Dramatic music rise, beat drops with impact narrator, VO. The engineering solution was an absolute financial nightmare. There was no way to patch the system. The repair required total, absolute replacement. Every single one of the 10,344 insulated glass units had to be ripped out of the building. They were completely discarded and replaced with monolithic, heavily heat-treated, tempered glass. This eliminated the flawed dual-pane sandwich construction entirely. Text on screen. The cost of overreach. Reglazing odd narrator. VO. The cost for this emergency reglazing alone was astronomical, dragging millions of additional yuan out of the developers' pockets. According to contemporary internal construction audits, the total bill for the replacement glass and accompanying structural reinforcement blew the budget wide open, pushing the final cost past 1 billion yuan, double what Huaxia Mutual Life had originally authorized. And here is the hidden twist that the developers didn't want anyone to talk about. The reglazing fixed the deadly falling object hazard, but it fundamentally crippled the building's utility. The original dual-pane insulated units were designed to provide superior thermal separation between the interior office spaces and the outside elements. The replacement monolithic single-pane glass did not. By stripping out the insulated sandwich layers, the engineers baked a permanent energy penalty into the very bones of the high-rise. The building now required massive, unsustainable amounts of electricity to run the heating systems during Shanghai's damp winters, and an even more absurd amount of energy to power the cooling chillers during the humid summer months. The Guanghua Tower finally looked like the clean, unbroken blue mirror its architects had dreamed of. The plywood patches were gone, but underneath that beautiful facade sat a fundamentally compromised envelope, generating massive hidden maintenance and utility penalties that would plague the owners for decades to come. And as the engineers were about to find out, the skin of the building wasn't the only thing that was broken. Deep inside the core of the 60-story tower, an even more terrifying structural flaw was waiting to be uncovered. Fada black, sound effect, drilling, metal metallic clanging reverberating through a hollow core narrator, VO. The crisis of the Guanghua Tower was no longer just an isolated embarrassment for Shanghai. It had rapidly evolved into a watershed moment for the entire high-rise construction boom sweeping across mainland China. To understand why this project sent absolute shockwaves through the regional construction bureaus, you have to look at the broader context of Chinese mega-project development during this era. In cities like Shenzhen, Guangzhou, and Tianjin, glass curtain walls and soaring vertical profiles were being adopted at a breakneck pace. Skyscrapers were symbols of economic ascendance, but the Guanghua Tower became a terrifying case study in what happens when the speed of architectural ambition completely outpaces the development of local engineering codes. Graphic fly-in, the skyline risk factor, comparing waterfront high-res narrator, VO. Every major coastal metropolis in China faces a relentless geographical adversary, extreme meteorological forces. From the typhoon-prone developments along the Pearl River Delta in Shenzhen to the soft, shifting alluvial soils of the Yangtze River Basin in Shanghai, building tall in this region means wrestling with nature on a monumental scale. When the glass began falling from the Guanghua Tower, engineering teams across the country suddenly looked at their own blueprints with absolute dread. If a premium, state-backed corporate headquarters in the heart of Shanghai's commercial center could suffer a systemic structural envelope failure, what did that mean for the dozens of other luxury high-rises and mixed-use complexes currently rising across China's Tier 1 cities? Animation, Chinese, Wind Zone Architecture Map, highlighting Severe Typhoon and Coastal Storm Corridor. VO. The core issue was that China's domestic engineering frameworks during this developmental era were still adapting to the unique aerodynamic demands of super-tall structures. Prior to the mega project explosion, local building guidelines were heavily optimized for traditional, lower-profile industrial blocks and masonry residential complexes. When elite architects brought ultra-minimalist, aerodynamic designs into soft soil environments like Pudong or the swampy riverbanks of Wuhan, they were operating on the absolute bleeding edge of physics. The structural failure of the Guanghua Tower's facade immediately triggered emergency inspections by municipal construction commissions across the country. Teams from the China's Academy of Building Research began cross-referencing the structural data of every major tower utilizing similar dual-pane insulated glass systems. What they discovered was a widespread systemic risk. The rush to implement futuristic, European and American-style aesthetic trends had led to a dangerous reliance on untested material bonds in highly volatile maritime climates. Effect: low-frequency wind tunnel, roar, narrator, VAO. But as bad as the facade crisis was, the real structural terror was exposed when forensic teams began analyzing the tower's internal response to lateral wind loads. This wasn't just a Chinese problem, it was a global engineering blind spot that manifested perfectly within the unique geographic conditions of Shanghai. When a severe storm system rolls off the East China Sea, it doesn't just push against a building, it wraps around it, creating powerful, alternating low-pressure vortexes that pull and shake the structure from side to side. In typical Chinese residential megablocks or heavy concrete commercial complexes, the sheer mass of the concrete absorbs and dampens these oscillations. But the Guanghua Tower was a featherweight by comparison. Its sleek, razor-edged rhomboid profile was incredibly light and flexible. When winds accelerated down the narrow street corridors of Wenhua Square, the aerodynamic forces began to induce a phenomenon known as vortex shedding. The tower didn't just sway, it began to twist and oscillate violently. Graphic computer modeling. The structural lack of marg under lateral force narrator, VO. The engineering disaster here was an absolute failure of oversight during the initial structural design phase. The design team had spent months calculating the wind loads hitting the broad, expansive faces of the blue mirror facade. They assumed that because the building had a massive surface area on its wide sides, that was where the primary danger lay. They were dead wrong. When independent structural experts put a detailed scale model of the tower into specialized high-velocity wind tunnels, the diagnostic readouts painted a horrifying picture. The building's true vulnerability wasn't its broad face. It was its narrow, razor-sharp profile. When high-altitude wind gusts slammed directly into the tower's narrow faces, the lateral resistance system was completely overwhelmed. The original engineering calculations had left almost zero structural margin for error. Under a worst-case typhoon scenario hitting Shanghai at a specific angle, the internal stresses would exceed the ultimate yield strength of the main steel columns. The implication was clear, undeniable, and utterly terrifying to the municipal authorities. If a major storm hit the city before the structural core could be reinforced, the tallest building in the commercial district was at genuine risk of a progressive catastrophic collapse. The Plywood Palace wasn't just a public relations disaster anymore. It was a 60-story structural liability, waiting for the wrong wind event to tear it apart. Fade to black. Sound effect. Wind howling mixed with the sharp, metallic screech of straining steel constructors narrator, VO. To fully comprehend the sheer scale of the terror unfolding inside the Guanghua Tower, you have to leave the corporate boardroom and step onto the upper executive floors. This wasn't a sterile corporate simulation, a theoretical math problem in a structural engineering laboratory. This was a massive, occupied high-rise in the absolute heart of Shanghai. And for the hundreds of office workers, engineers, and maintenance crews who walked through those doors every single day, the building's hidden defects were a terrifying daily physical reality. Let's meet Zhang Wei. In the mid-1970s, Zhang was a senior data analyst working for a state-backed trading enterprise that had leased space on the 52nd floor. He recalls the precise moment he realized that the gleaming, high-tech monument he worked in was fundamentally broken. Zhang Wei, actor reenactment, voice-over. It was a typical late autumn afternoon when a sudden storm front rolled in from the East China Sea. The wind gusts were hitting the upper floors at well over 85 kilometers per hour. I was sitting at my desk when my teacup began to slide horizontally across the polished wood. Then came the sound, a deep, agonizing groan from inside the walls, like thick metal plates being slowly ground together under immense pressure. Within an hour, half the staff on our floor was experiencing severe motion sickness. People were literally throwing up in the restrooms from the constant, rhythmic swaying of the floorboards. It felt like being trapped on the bridge of a cargo ship in the middle of a typhoon, but we were 200 meters up in the air, bolted to the ground. Graphic. Wind velocity vs. Oscillation amplitude chart on 50-plus floors narrator. The dynamic response of the tower to Shanghai's intense coastal winds was so extreme that it completely disrupted daily business operations. But while executive staff were dealing with nausea and shifting furniture, the engineering teams stationed in the basement were facing a far more sinister reality. Whenever the local weather bureau issued high wind warnings, the Municipal Housing Bureau and Fire Rescue Services would place the entire surrounding area of Lime Road on high alert. Imagine a luxury commercial district completely paralyzed by a breeze. The moment wind speeds crept past 45 kilometers per hour, emergency sirens would echo through Wenhua Square. Police officers would sprint down the avenues, unfurling blockades and forcing pedestrians into underground metro channels or under heavy concrete awnings. The threat of a 220-kilogram glass pane obliterating a pedestrian was so constant that the local population lived in a state of hyper-vigilant anxiety. Sound effect, explosive impact, shattering glass, reverberating across concrete narrator. And then, the litigation exploded. Across the street, the leadership of the historic Shengji Temple, led by a senior administrator named Master Chen, had watched their beloved National Historic Landmark undergo a slow, agonizing destruction. The structural displacement from the tower's initial, botched foundation excavation had left deep, irreparable scars across the temple complex. Let's look at the cold, hard numbers from the devastating property damage report filed with the Shanghai Superior Housing Court. Affected structure, element documented destruction, structural impact main sanctuary, load-bearing walls massive, vertical fractures, splitting along historical mortar joints. Structural stability compromised. 19th century stained glass and facade severe frame distortion. Custom historic glass units shifted out of alignment and fractured under pressure. Interior sacred murals and plaster extensive shearing and flaking due to continuous structural vibration and ground settlement. Subsurface foundations catastrophic lateral soil displacement. Western foundation pile caps dropped by several centimeters. Narrator. VO Master Chen and the Temple Preservation Committee refused to be intimidated by the multi-billion yuan financial backing of the Wasia Mutual Life Insurance Company. In 1975, they launched a massive, unprecedented civil lawsuit against the developers,
alleging gross negligence during the deep excavation phase and a total failure to protect a designated national heritage site. The legal battle became a public relations bloodbath for the insurance giant.
The technical defense teams for Huaxia tried to argue that the cracks in the temple were the result of natural aging and traditional Shanghai soil settlement. But the forensic engineering data was undeniable. The temporary steel retaining walls of the tower had deformed by several millimeters, directly siphoning the stable clay and mud from beneath the temple's centuries-old foundation. The court did not mince words. The jury found Huaxia entirely liable, awarding the temple an unprecedented $4.17 million in direct damages. By the time interest and accumulated legal fees were tacked on over years of bitter appeals, the total liability skyrocketed past $11 million. It was a staggering, highly publicized defeat for a major corporate institution at the hands of a historic religious landmark. But while the lawyers were fighting in the courtroom, an even more radical, highly dangerous intervention was taking place inside the tower itself. Sound effect. Heavy industrial cranes hydraulic rebever, resounding inside an atrium narrator. VO. Because the independent wind tunnel tests had shown that the tower could potentially collapse if hit by a severe typhoon, engineers had to perform emergency, high-stakes structural surgery on a fully completed, 60-story building. This was an operation of absolute desperation, conducted almost entirely out of sight of the general public to prevent widespread panic across the city. First, they had to tackle the nauseating lateral sway. To do this, elite engineering teams invaded the 58th floor and installed a technology that was practically unheard of in mainland China at the time: a double-tuned mass damper system. Graphic: X-planar diagram, showing the mechanical operation of a tuned mass damper noverator. VO. This system was an absolute mechanical titan. It consisted of two massive solid steel boxes entirely filled with dense lead blocks. Each box measured roughly 5.2 meters square and stood nearly a meter high. Together, these twin lead monsters weighed a jaw-dropping 600 tons. They were placed directly onto heavily lubricated steel plates and anchored to the building's primary structural core using a complex network of high-tensile steel springs and massive hydraulic shock absorbers. The physics behind it were brilliant but tragic in their necessity when a vicious wind gust slammed into the skyscraper, pushing it to the left. The 600 tons of lead would lag behind due to pure inertia, smoothly sliding to the right and pulling the structural frame back toward the center of gravity. This emergency comfort upgrade alone drained another $3 million from the project's depleted reserves. But the 600-ton lead damper only solved the motion sickness. It did absolutely nothing to fix the underlying structural vulnerability of the building's narrow faces. To save the tower from a catastrophic progressive collapse, crews had to implement a massive structural reinforcement campaign. Sound effect: sparks flying, heavy welding torches hissing narrator. The Ivemall working around the clock, deep inside the service cores and mechanical rooms. Ironworkers bolted and welded an astonishing 1,500 tons of heavy diagonal steel bracing directly into the existing framework of the tower. They supplemented this with 300 custom-fabricated, heavy L-shaped steel reinforcement beams designed to lock the narrow sides of the skyscraper into a rigid, unyielding grid. Think about the sheer madness of this scenario. This wasn't a building under construction. This was a completed skyscraper. Workers had to tear through finished walls, rip up commercial flooring, and bypass existing electrical and plumbing systems just to weld thousands of tons of emergency steel directly into the bones of a structure that was supposed to be a completed masterpiece. The structural surgery cost an additional $5 million and added thousands of tons of dead weight to a foundation that was already sinking into the unstable Shanghai mud. Sound effect: tense, dramatic interaction underpin. The continuous danger narrator. VOFO yet. Despite the emergency steel bracing, despite the 600 tons of lead dampers, and despite replacing all 10,344 glass panes with tempered single-pane glass, the building authorities remained completely terrified of its facade. The relationship between the tower and its own exterior skin remained profoundly broken. To prevent another catastrophic falling object event, the building management was forced to implement a surreal, low-tech monitoring system that sounds like something out of a dystopian satire. They hired a full-time team of building lifeguards. These were specialized structural spotters stationed at strategic vantage points around Wenhua Square and on the roof of adjacent high-rises. Every single day, equipped with high-powered military binoculars and specialized polarized lenses, these spotters would meticulously scan the 60-story blue mirror. Pane by pane, row by row, they were looking for a highly specific, terrifying visual indicator: a deep, localized darkening of the reflective chromium coating. In the specialized engineering jargon of the Academy of Building Research, this darkening was a clear sign of extreme, localized mechanical stress, a warning that the underlying glass structure was undergoing internal microfracturing and was preparing to fail. The moment a spotter flagged a darkened pane with their radio, emergency maintenance crews would scramble into window-washing cradles, drop down the side of the skyscraper, and pry the panel out of the frame before it could shatter and rain down onto the streets. A premium, billion-yuan office tower in the most prestigious commercial center of East China literally required full-time human surveillance just to keep its walls from falling off and killing innocent people. The dream of seamless architectural minimalism had transformed into a multi-million-dollar engineering prison. Fade to black. Sound effect, low, resolving synth not echoing into a cold metallic drone narrator VOIFO. The great irony of the Guanghua Tower finally culminated on September 29, 1976. Roughly 5 years behind its original schedule, the tallest skyscraper in East China finally opened its doors for general commercial occupancy. By that point, the project had mutated into a multi-million-dollar urban tragedy. The final spreadsheet was a damning indictment of corporate and architectural overreach. The building had cost more than double its initial estimate, crossing into the billions of yuan. It had physically undermined and fractured a national historic landmark. It had rained over 100 heavy glass panels onto public avenues, turning a bustling commercial square into a military-grade exclusion zone. It had been covered in a hideous patchwork of blue-painted plywood for years, earning the ridicule of the entire metropolis. And it required 600 tons of lead weights and 500 tons of emergency steel bracing welded into its core just to guarantee it wouldn't collapse during a coastal storm system. And yet, just 1 year later, in 1977, the National Architecture Association handed its highest honor award to the design team, Graphic Fly-In, the Duality of Architecture, Professional Acclaim vs. Real Wound Facier Narrator, VO. That striking contrast between elite professional praise and the terrifying reality of public experience captures the entire systemic sickness of mega-project development. The high-minded architectural juries saw a building of sublime proportions, a clean geometric mirror that gracefully interacted with its urban site. The citizens of Shanghai, however, saw a building that cracked their sidewalks, closed their public transit routes, and couldn't keep its own skin from falling off. Both of these realities were completely true at the exact same time. The legal fallout from this architectural disaster would stretch well into the next decade. In 1975, Huaxia Mutual Life Insurance filed a massive, sweeping civil suit against Chen and Partners and 5 other major construction and manufacturing subsidiaries involved in the design and production of the original curtain wall. The insurance giant sought to recover every single yuan spent on the emergency reglazing and structural interventions. But if you are waiting for a public trial that exposed all the technical secrets and held the elite designers accountable, you are going to be severely disappointed. In 1981, the entire case was quietly settled out of court. The financial terms were permanently sealed. The strict non-disclosure agreements that had choked the engineering investigation from day one were extended into the legal resolution, creating a permanent wall of corporate secrecy around the full financial and technical failures of the tower. Graphic, Skyline Travel Pan. Transitioning from historic footage to contemporary Shanghai shot narrator, v today. The skyscraper still stands at its prominent location on Limay Road, now operating under a completely different corporate name after being acquired by a major commercial property conglomerate. From the outside, the tower looks exactly the way Lee Henry intended it to look over 50 years ago. It is a serene, pristine blue mirror reflecting the ancient gables of Xingji Temple and the bustling modern streets of Shanghai as if nothing ever went wrong. But that serenity is a complete corporate illusion. Beneath that flawless blue skin lies a hidden museum of structural trauma. The twin 300-ton lead boxes still sit on the 58th floor, silently sliding back and forth to counteract every wind gust coming off the East China Sea. The 500 tons of diagonal steel bracing remain bolted and welded inside the internal walls, completely invisible to the thousands of finance workers who walk the halls, but absolutely essential to keeping the structure from tearing itself apart. The single-pane replacement glass still penalizes the building's operators, pulling massive amounts of power from the municipal grid every winter and summer to offset the total lack of thermal insulation. Music modulates to a grave, final tone narrator, VO. The Guanghua Tower remains a mandatory case study taught in every elite engineering university across mainland China. It stands as a permanent monument to what happens when cutting-edge materials, aggressive aesthetic ambition, and highly volatile soil conditions collide without adequate testing. The building, designed to honor its historic neighbor, nearly brought it crashing to the ground. The facade meant to disappear into the sky transformed into a vertical firing range, and the massive insurance corporation that built its entire empire on managing other people's risks proved completely incapable of managing its own. It is still a dominant silhouette on the local skyline, but it is also a chilling reminder that in the world of high-stakes mega projects, the distance between an architectural masterpiece and a lethal engineering disaster is sometimes just a few millimeters of rigid solder on the wrong side of a glass panel. If you want to understand how the world's biggest engineering projects go catastrophically wrong, and what happens when corporate ambition overrides public safety, make sure to hit that subscribe button. We break down these structural mega disasters every single week. Drop a comment below. Would you work on the 60th floor of a tower stabilized by 600 tons of moving lead? Let us know, and we will see you in the next investigation. Fad to Black.